Run it again. Okay, we are now seeing these are split apart according to which of the 3 items they were associated with. I'm looking for this life expectancy data, and I know that this sort of particular part of the URL is that. And I know that the particular part that is going to tell me in this JSON what we're actually going to have as the value is this numeric value thing right here. So I'm going to go ahead and pop that into the code so that I don't have to just look through all of this. Let's give this a name. What shall we call this? We'll call this just the JSON. And then we can go ahead and get out from the JSON whatever is the portion that we are looking for. So JSON, I think this is inside the value. And we only want to get one item, this numeric value. So let's call that something. Let's maybe call that life expectancy. So now I want to go ahead and print out country code, this value right here. We just have to make sure that we've stored it, we've saved it, we've given it that name before we actually use it. Let's print out both the country code and the life expectancy, and let's see if we're getting the data that we're expecting. Looks good. You can see the life expectancy for these 3 countries that we were looking at. Okay, let's go ahead and actually save that data because maybe we want to do something else with it later. So let's make a new list. This one will be empty, and we're going to go ahead and fill it with the data that we're grabbing from these calls to the requests library, from going out to the web and saying, bring me back the data for this country. Let's keep on printing it too. Let's also go ahead and add it into data. So we will append to the data list, and we'll go ahead and put in country code and life expectancy. Let's print out our data at the end of the process just to make sure that this is actually looking like we're expecting it to look. I'll run the program again. Okay, we are seeing that data at the end. What if we put it on a map? Again, we're going to want to use a nice library that's something that we built for us. So let's import plotly.express, and we'll call that px. So now, instead of just printing the data, let's also make a figure that represents the data. So fig equals px.chloroplet. Let's use our data. And now we're going to have to tell it what are the locations and what are the things that we want to visualize in this. So I'm going to say locations. And I'm going to have that be 0, meaning it's the 0th item in each of these pairs. We can see that right here. We can see country code is on the left, so it's the 0th item. And then life expectancy is the 1th item, or in the sort of more usual terminology that you and I would use day to day, it's the 2nd item. So let's go ahead and say color equals 1. And once we have actually got that, let's actually show the figure. So here we go. We've got our program ready to go. Fantastic, we can see our little map. Here it is. It's got those 3 countries colored. We probably are interested in doing it for all the countries, so I'm just real quick gonna go in here and actually change which of these lists we're using. So you can see that we've just been using these fewer country codes just as the 3, but why not run it for all the countries, right? The data's there. So let's go ahead and use some country codes instead of fewer country codes. And let's get rid of all these old unnecessary lines, and then we will have our final program. So here we go. It is going to talk to the internet. It's going to collect the information for all those different countries. And after a few moments there, I think it was a little under a minute, we've got our map. It's got the data for a bunch of different countries. HGMIB926 asks, how do I read code? This is honestly an incredibly difficult question to answer because reading code is actually really hard. It's not like when we're sitting down to a piece of text. We're going to start on page 1, we're going to go to page 2. We're moving in this sort of linear manner. That's not how we typically do it when we're reading code. Don't take this advice if there's any chance that your code might be malicious. But if this code is not malicious, go ahead and run it. Take a look at a part of the output that you are interested in, you want to follow up on. Go figure out what part of that code actually created that output, and then start working your way back, right? What were the outputs that came out of some earlier part of the code that ended up going into the process of making that output? There are even debuggers that are specially built to sort of help you work through individual executions of code. So one of my favorite kinds of debuggers that I really like is called time travel debugging. You've gone ahead, you've done an execution of your program that you're interested in, but maybe you actually want to walk it back. You want to travel back into the past to see what was happening before. You can go ahead and do that. If you then want to travel ahead, you can do that, thus time travel. Vitro3 asks, how do computers understand code? I'm going to talk us through it with a specific concrete program. I'm going to show us how we get from something that looks kind of like a computer program that you might have seen places, all the way down to the 1s and 0s that you can then actually store in the machine. And we'll draw the 4 stages that we take it through. So this is going to be, just the input to this entire process. So here we go. We've got 1 plus 2 plus 4. Now, the very first thing that needs to happen is I have to figure out which portions of this to treat separately versus together. I'm going to just do that by underlining. So the left parenthesis is going to be on its own, one is going to be on its own, the plus sign of the 2, the right parenthesis plus 4. You can see we've ignored these spaces. We've got our left parenthesis, our 1, plus our 2, our right parenthesis, our next plus, on our 4. This stage, what I've just drawn out, that is called flexing or tokenizing, because the things that you see in this list on the right are the tokens. So the next thing we're going to want to do is turn this into something that we can actually sort of use to understand something about the structure of this program. So here, at the root of something that I'm going to call a tree, we're going to have the addition operator, and this is going to be the operation that's going to actually happen second, because what we want to do is we want to make sure that that 1 and that 2 that we're adding together, you can see that those are in friends, we actually want to do that first, right? Because that is from the group. We'll have a 1 on the left and a 2 on the right. And then what we have on that last branch there of the top add is going to be that 4. Now we can start to see that there's some structure happening here. We can see that sort of the 1 and the 2 are going to be grouped together by some operation, and then whatever we get out from that operation, that's going to be grouped together with the 4. So actually, a lot of folks know that what goes into the computer eventually has to be 1s and 0s. And there's no clear way necessarily at this point to turn this into 1s and 0s. So now we're going to turn it into something called instructions. And instructions are basically just going to be the things that the processor knows how to handle. So here we go. We're going to go ahead and write out move 1, right? Because that's the first value that we're dealing with, into R8, one of the slots that the computer has available. And then maybe we will move into R9, another slot, the value 2. We now have everything we need to do in order to run our first addition. So let's go ahead and do an add instruction, and we'll go ahead and add together what we've got from R8 and R9, and that is going to put that value inside R8. So now let's go ahead and move that 4 into one of these. So we're no longer using R9 anymore, the thing we were previously using. Let's go ahead and move into R9 the value 4. And now if we do add R8, R9, we should get the result of the entire program in there. And then this phase, where we're actually taking that nice structure representation of the program and turning it into instructions, that is actually called code generation. But at some point, it actually has to turn into 1s and 0s. So let me go ahead and highlight some common structure that we're seeing across the instructions. You can see that there's sort of this thing, and then there's this thing, and then there's this thing. And it turns out that we have a scheme for turning each of these into a binary number. And then we do the exact same process for all of those instructions, and finally what we have is just 1s and 0s. So now I'm going to turn to the computer. So here we are in something called x86-64 Playground. This is just a website. You can visit this on your browser. I have typed in the instructions that I was drawing over here on the iPad, and so we're now going to get to see what it actually does for representation of the computer state when we're running through these instructions. So here we go. We'll start with that first move instruction. You can see that over here in R8, we now have the value 1. So let's go ahead and run the next step. Fantastic. We can see that now inside R9, we've got that 2 value. If we keep going, we're now going to see that we've done the addition, and the output from that addition, the value 3, that now lives inside R8. Fantastic. One more. We've got moving the 4 into R9. It's okay for us to reuse R9, right? We're not overwriting anything that we're going to need later, so it's totally fine. We can go ahead and get that value into R9, and then one more, and we can see that we've done that last addition, and we've got the final output 7 represented inside R8. And that is how the computer understands the code that you write. That's it. We have run out of questions today. I hope you all learned something new. I hope you're excited about programming languages and maybe even about compilers. Until next time.
我小尾鳍呢？
Accept over.
3, 2, 1, go!
아마 그래 뭐 하고 저기까지 그걸로 갔을 때는 집에 보내
Game.
Let's do that again sometime.
Solo battle.
Let's do that again sometime.
Solo battle. Pikachu.
Về bọn mấy kẻ chiến 내가 뭐걔 진짜야 보면
걔안 맞냐?
어찌나 있어야 돼.
One. Go.
또 랭고 랭고고